Hello everyone, welcome back to another video, and in this video we'll talk about an entire roadmap for data structures and algorithms. Now if you don't know anything about data structures and algorithms, if you are basic, you have like basic to medium understanding, you can still watch this video. This video is definitely recommended for you. We'll start from the very basics, from let's say you don't know anything about programming to like learning data structure algorithms till you can clear your coding interviews, for example. So this video is for all type of learning levels. If you're just starting off, you don't know what programming is or anything, we'll start from the very basic, right from where to pick the language from and how to learn that language, which all data structures and algorithms to learn, and the most important part, which is the question we get quite a lot: in which order to learn. Okay, so when to learn which algorithm, then which data structure, then which algorithm, so on and so forth. So without further ado, let's get started. And I just want to share, please make sure you like, share and subscribe, and please subscribe to Code for Cause and share your views in the comment section. We love reading the comments, and these particular videos are going to help you quite a lot. Check out the guidance playlist once. It's going to answer almost every question that students ask us, and share it with your friends as well. And because we are doing such amazing work, I wanted to reach to every particular student, at least in India, if not abroad, because we're still trying to I'm trying to make content that is more accessible to people outside India as well. But please try to please share it with other people and show your support. Cool. Awesome. First things first, programming language, right? So in programming language, the most popular ones, when we ask about data structure algorithms: Java, C++, Python. One thing I want to point out is C++, in order to learn C++, you don't have to learn C first. So I just wanted to point that out over there. Now, which of these programming language would I recommend for data structures algorithms? If your end term goal is just let's say doing a little bit of comparative coding, clearing the coding rounds, and also doing some development and stuff, I would recommend Java, because in C++, until and unless you want to go for very high ACM ICPC worlds, best comparative coding is something your aim, then okay, I think that's fine. But if that is not your aim, if your aim is only to clear FANG interviews and do some code chef, code forces, lead coding, and take part in various other competitions as well, Java is great. If also you want to contribute to open source and make projects, because contributing to open source in C++ is quite difficult at most time for students, because the projects are very complex. If you feel like you are able to put in that much efforts, then go for it, but I would recommend Java. Python is okay, it's great, but as a beginner, many details are hidden in Python. There's a lot of abstraction layer. That is why Java is my best answer for you all. And now starting out, let's say you don't know anything about programming, start out with write some pseudo code about some particular quizzes or something, small questions, flow charts and stuff, and learn about control flow statements. So how a control from one program is going to another program. You can make a simple program of printing numbers from 1 to 10, for example, taking an input number n and printing a table from 1 to n, for example. After that, now let's talk about how to start with coding part, setting up your development environment. For Java, IntelliJ IDEA, C++, VS Code. For Python, you can use Atom, Sublime, or PyCharm, for example. Cool. Now, let's talk about learning the programming language. This is our next step. Notice, please follow these steps in the order that I'm sharing with you. Learn about data types, be that primitive data types or things like that, other data types, which we'll talk about later on. So after that, you learn about also input and output in your particular programming language. Learn about the coding standards in that particular language, like the syntax and all these things, and how the code is actually executed and stuff. And then also learn about functions. So in functions, you have to learn about the basic syntax of functions, what is taken in the arguments, what is taken in return values, and all these things. And then also solve a few problems, basic problems, printing hello world, some other problems printing numbers from this to this, taking a input and calculating something, making sum of two numbers, for example. Taking multiplication, tables, and for example, so many things. And then you can also learn a bit about debugging. Next topic is learn about arrays or like array list in Java, and like vectors in C++, and lists in Python. So in that you have to learn about like the introduction to those data structures like arrays, input and output, and traversing, how actually it is traversed. Linear and binary search, you have to learn about linear and binary search. This is one more topic, like this particular algorithm, binary search, very, very important. While you are learning about linear and binary search, do questions on searching as well. Now let's talk about sorting. In sorting, at first you have to learn about selection sort, bubble sort, insertion sort, count sort, and do questions related to this as well. How to do questions? Go to lead code, filter categories. You can see categories like binary search and sorting. Once you do that, if you're starting out with learning, solve the easy to medium questions. Don't need to solve the hard questions right now, but do this while you are learning these particular topics as I am telling you. After that, learn about multi-dimensional arrays like 1D, like 2D arrays, and n-dimensional arrays. After that, learn about rotation in arrays, and in that also you have to do questions like rotated binary search and all these things. After that, learn about dynamic arrays, like in Java we have array list, in C++ we have like vectors, and in Python we have normal lists. Learn about that, do questions about that, learn about its space and time complexity in brief only. After that, do interview problems on arrays and array lists. Just do a Google search, you will find many, many questions. Next topic is number theory and bit masking. So learn about Euclidean algorithms, learn about C of Eratosthenes. It's for like prime numbers. So yeah, learn about prime numbers, learn about HCF, LCM, basic stuff, number theory, and learn about then bit masking operators. So like AND operator, OR operator, NOT operator, exclusive OR, XOR, and all these things, NAND operator. Learn about these things. Again, do questions on these things on lead code. And after that, learn about like, what are the advantages, why we use bit masking, cost effectiveness, and then you learn about a little bit, you can say, and a little bit about the interview problems of bit masking, because there are quite so many. Next data structure you will learn about is strings, and in Java there's something called string builder. So in general, just strings, so learn about like introduction to strings. And if strings are in that language like mutable, so learn about like mutability and what the behavior is, and learn about like string pool and need of like how to compare string values. So there's like equal to versus is in Python, for example, and in Java there's like dot equals to method and equal to comparator. Learn about all these things. Learn about string operations, what the cost of that is. Learn about like something I should have mentioned before as well. Learn about memory management. Learn about stack memory and heap memory, and how all the objects are being compared. Like you say A is equal to 10. A is your reference, 10 is your object. It is pointing to the object. So 2 or more references can point to the same object. This is something you'll learn in object-oriented programming. So I'll mention that later on. Don't worry. Till now, just focus on the entire roadmap I have shared with you right now. And last but not least, learn about like string builder operations and optimizations if you're doing Java, and learn about string manipulation. Do questions on strings as well. Again, you can find these on lead code. Topic number 5 is now space and time complexity analysis. Again, go in order, like I'm saying it to you. Now learn about best case, worst case, and average case. Learn about sandwich theorem. Learn about recurrence relations. Learn about big O notations, theta notation, omega notation. Understand complexity of various loops. So we already covered like in conditions when I already mentioned you were talking about while loops and for loops. Now understand the complexity of this. Understand space complexity, auxiliary space versus total space. Understand static and dynamic memory allocation. And for this, you can take a look at the intro to time complexity video I did on Code for Cause channel. So Code for Cause channel has a playlist called workshops. In that workshop playlist, you can find an entire webinar, so many hours long webinar on specifically space and time complexity. I have also shared many ways via which you can solve recurrence relations, which we'll talk about next. So that is the next topic, which is recursion and backtracking. So now you already know about various standard data structures, searching, sorting, about arrays and all these things, and about functions. So now the time is to learn about recursion. Learn about recursion, like what is recursion, why we use recursion, when do we use recursion. Learn about the control flow and the stack trace. Try to visualize recursion when you're doing like the stack trace and on pen and paper. And understand the recursive tree. Okay, then in this you will learn 2 more sorting algorithms which use recursion. Very, very important one, merge sort and quick sort. And do questions on these particular topics. After that, do interview problems on recursion like maze path, and backtracking problem, Sudoku solver, n queens problem, lexo permute, permutations, rat in a maze, and strings plus recursion. So just Google string plus recursion questions, do that, and Google backtracking problems. On LeetCode you can find backtracking problems. Again, in this video I'm actually not going to go in detail obviously of every particular topic. I'm just giving you a roadmap, and all of this is entirely up to you. By the way, if you want an entire particular code structure, like a course for this particular roadmap, you will not find it on YouTube, I believe. For that, you can, if you do find, let me know as well. But you can definitely check out the Code for Cause courses that we have to offer. We cover entire thing, like from 0 to 100, everything that I just mentioned and I'm about to mention. I'll leave the link to that in the description below. Make sure you check it out. We have that for Java as well, C++ as well, Python as well, and most recently we'll do it in JavaScript as well. So any particular language you like, you can do data structures in that. Topic number 7. After that, after all the topics you have covered, now you have to learn about object-oriented programming. So learn about classes and object, learn about constructors, states and behaviors, learn about the object reference keywords like this in Java, self in Python, learn about the core object-oriented concepts like abstraction, inheritance, polymorphism, and encapsulation, learn about what the differences are in all of these, learn about access modifiers, learn about static and non-static fields, and learn about like final and finalize and finally keywords and things like that. So that's about your object-oriented programming, and make a lot of projects in this. This is now the part where you can definitely make projects like book reservation system, railway management system, ticket booking system. Now make projects like this. Now let's talk a bit more about in detail about more data structures algorithm focus on, because currently we were focusing on programming language. Now we'll focus on data structures algorithms. First one after this you have to learn is stacks and queues. After the object-oriented programming you have done. So learn about stack as a generic collection, learn about operations in a stack, learn about stack using arrays and linked list, learn about push efficient and pop efficient stacks. This is also very important interview problem. You can learn also about now queues. So queues as a generic collection, as an abstract data type, operations in a queue, and queue using two stacks. This is another popular question. And after that, you can do interview problems on stacks and queues that you can find on LeetCode. Next topic is linked list. So learn about introduction to linked list, learn about the implementation of linked list. Same for stacks and queues. Whatever thing you're using, be that, let's say you are using stack that is already implemented, also try to implement that on your own, because now you have learned object-oriented programming. So you can implement that on your own. Same thing for linked list. Introduction to linked list, implementation of the linked list, operations in linked list, cycle detection algorithms, and problems based on linked list. In linked list, also I can share some algorithms for you, like fast and slow pointers, for example, cycle detection problem, for example, so all of these are like the patterns that I mentioned. Go to LeetCode and solve these problems. Next data structure you have to learn is binary tree. So learn about the implementation of binary tree, learn about tree traversals, pre-order, in-order, post-order, learn about searching algorithms, the most important part, DFS and BFS algorithms, calculate like the height of the tree, depth of the tree, diameter of the tree. Go to the LeetCode trees section and do all the popular questions. You will be good to go. And learn about like the implementation of binary search tree and why we are using that, learn about its time complexity, why we use binary search tree, and then learn about like AVL trees, which is like self-balancing binary tree, learn about that, learn about its rotations, and then most important part, learn about the two interview problems on binary tree and binary search tree. Again, you can find these on LeetCode. Do easy to medium level questions. Don't worry about hard questions. Next data structure you will learn about is heaps and hash maps. So learn about the implementation of heap, why we use heap, time complexity of it. Learn about priority queue as a generic collection. Learn about heap sort. This is another particular sorting algorithms. Learn about its complexity analysis. Learn about now hashing, the concept of hashing, and learn about various ways in which we can implement hashing. Learn about like the hash map implementation using like array list, linked list, and collision detection, for example, how to resolve collision. Learn about like open chain addressing and stuff, and then learn about like types of maps in that particular language. In Java you have many maps, you have like tree map and stuff. In C++ you might have something else. In Python you have dictionaries. Learn about all these things. And the most important part after this is problems on hash map and heaps. Heaps has many problems, like given n sorted arrays, make one sorted array and things like that. Do questions like this. And there's like there are questions related to like My questions, I'm telling you questions that you have to do. So there are questions like time intervals, find a time interval in which everyone is free. In that also you use heap and stuff. Try to solve all these questions again on lead code. Now the last, like not the last, but we are getting close. Next topic is graph. So learn about the basics of graph, terminologies in graph, learn about like edges and vertices, and implement the graph in your own, using your own, like you can do an edge list implementation, like make a list of all the edges. For example, there's another popular one called adjacency list implementation, adjacency map implementation. Try to see which one is being used when. There's a table implementation as well. Now learn about like searching algorithms in graphs like DFS and BFS. Learn about other topics like connected components, cycle detection, path finding algorithms like Kruskal. You can say like more like, this is more like the Kruskal and Prims is more like for minimum spanning tree. So learn about like minimum spanning tree, learn about like path finding stuff like Dijkstra algorithm, learn about Bellman-Ford, for example, if you have like, negative weights and stuff. And after that, do questions and also learn about topological sort. Cool. Topological sort, another good question in which you can like learn about, another good topic in which you can have like so many interview problems coming to you. Last but definitely not least, most important topic, dynamic programming. You have to have your recursion and functions concept clear in dynamic programming. So understand the basic concept of dynamic programming, understand the overlapping sub-problems, memoization approach versus tabulation approach, learn about top-down approach and bottom-up approach. One of the most popular algorithms is 0-1 knapsack problem. Learn about that. Learn about the wildcard pattern problem. Some other problems I can give you are like egg drop problem, matrix chain multiplication. And then after that, only thing that will let you have confidence in dynamic programming is only solving questions on LeetCode and other platforms. That is it. Go to LeetCode, go to dynamic programming, sort it according to like easy to medium level and also the number of popularity. Do all those questions. If in dynamic programming you don't do questions, you will not succeed. So I will now tell you approach to solving LeetCode problems and more specifically dynamic programming solution. So in any problem you are solving, don't give more than 30 minutes to that problem or at max 40 minutes to that particular problem, because what will happen is like take any particular problem, solve it for like 15 minutes. And after that, what you can do is, if you're not able to solve it, look at the hint. If you're not then also not able to solve it, look at the final solution and then come back to that particular problem after 1 week. So even if you're giving like 5 hours daily, so if you're giving like 5 hours daily, you will be able to solve around 10 questions, if you're giving 30 minutes per question. Now, let's talk about dynamic programming questions. First things first, for every question, do this. If you're learning, do the recursion solution, which is the most simplest one. Do recursion plus dynamic programming solution. For each of these solutions, what you have to do is also calculate space and time complexity. After that, convert it into a iterative solution, which is like your tabulation form, and each particular in iteration you will basically be using matrices. So figure out, write it in words, what each particular cell of a matrix represent. Now you will not be able to understand, but when you are doing this, come back to this video and watch this particular part of how to actually how to actually learn dynamic programming solutions. That's the third point, iteration solution, and write it in words. What does the tabulation represent? And fourth point is iteration plus space optimized. Okay, this is also something that I leave up to you for Googling and learning. Again, you can also join the Code for Cause course and we'll be covering everything in detail. And then just do questions. After that, you will have a strong foundation. This is going to take, if you give your dedication, it's going to take around 3 months. If you are truly dedicated, around 3 months, 3 to 4 months, it will take to do this entire structure that I mentioned to you. After that, only thing you have to do is regularly, daily practice questions. That's it. That was about it. If you like this video, please share it with your friends. Do check out the courses in the description. If you have any questions for me, find my Twitter handle in the description. You can share and my Instagram handle as well. But the most important point is the Code for Cause handles and the Code for Cause meetup group. Please join all the links so that you don't miss any announcement. Press the bell icon, subscribe to the channel, show some love, share it with your friends. Some amazing content is coming towards you. We're going to be sharing so many amazing initiatives, internships. We're going to be sharing about like, hackathon events, big prizes coming for you. So many things coming for literally like, thousands and thousands, like you have no idea how much amazing things are coming towards you. Please join the Code for Cause community. Literally the biggest prizes, biggest hackathons, biggest events are coming your way. Literally, the prizes are next level. So you will find so many amazing content about all of these other amazing events going on in the particular area for the student community, to help you all get involved in open source and all these other amazing initiatives. We have one very important event this by CNCF, Cloud Native Computing Foundation, swags opportunity and internships, networking, everything will be discussed on 12th at 7 p.m. IST. I'll share about it soon. Please make sure you share about it with your friends and share and subscribe to the YouTube channel. And I'll see you all in the next one. Have a great